ordinary differential equations of first order reducible to exact form. Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir. In the previous video, we worked on the theory of exact differential equations and we also solved some very important exam problems on the same. If you haven't seen that video yet, then I highly recommend you to checking it out first, because today's topic is directly connected to it. The link you can find in the description below, or you can also refer the VTU engineering maths and playlist. You can find other topics over there, referring which we can get good marks in the examination. So please watch and come back here for a smoother continuation. So in today's video, we are going to start with the continuation of exact differential equation, that is equation reducible to exact form. See, previous video we seen what is exact differential equation. That is a equation of the type of the ODE or the ordinary differential equation of the type m dx plus n dy is equal to 0 is exact only if the condition satisfied, that is dou m by dou y is equal to dou n by dou x. Then we have the solution integration of m dx plus integration of n, only y terms into dy is equal to c. But what if the condition does not satisfy? What if dou m by dou y is not equal to dou n by dou x? Such equations are called reducible to exact form. See, there are many types of reducible to exact form equation, that usually there are 4 to 5 types, but with respect to the VTU syllabus, you have only one type. Easy, right? So today we are going to study that type. So to understand the concept of reducible to exact form, let us go back to the previous theory. Say we have the general form of ordinary differential equation or ODE as m xy dx plus n xy dy is equal to 0. This is the general form of ordinary differential equation. Now for this form, the condition to be exact was what? Dou m by dou y should be compulsory equal to dou n by dou x. That is, the partial derivative of this m term should be equal to, with respect to y, should be equal to partial derivative of the n term with respect to x. Okay. Then what it is what? It is exact. But if this is not equal, if dou n by dou y is not equal to dou n by dou x, then this is what? This is not exact. If it is not exact, then what to do? Such forms are called reducible to exact forms. Okay. So if it is not exact, then what to do? To solve we make it to exact form. That is why we call it reducible to exact form. How we do it? There is a very simple method here, understand it. See, m dx plus n dy is equal to 0, dou m by dou y is not equal to dou n by dou x, so not exact. Getting it? So if not exact means we find the difference. Which difference? This difference. We find the difference of dou m by dou y minus dou n by dou x, and that should be what? The difference should be near to m or n. Understand this. The difference should be what? It should be near to m or n. That means it should look, the question given m dx plus n dy, when we find the difference of dou m by dou y minus dou n by dou x, the value what you will get should be little what identical to the m term or the n term. Getting it? Now it is near to m or n, then what to do? If say now comes here, if near to m, if near to, say I will take n first, near to n, okay, if the value is near to n, then find 1 by n into dou m by dou y minus dou n by dou x, this difference, 1 by n minus this difference, and that is taken as what? F of x. Understand, it is taken as what? F of x. Therefore, the integrating factor I call it as IF is equal to e raised to integration of f of x dx. Very, very important. What is that? Integrating factor is equal to e raised to IF is equal to e raised to integration of this f of x dx. Getting it? Integrating factor is a value, okay, which when multiplied with a quotient makes it exact. That is what reducible to exact form means. Getting it? So, here now the next thing, see carefully, if it is I have taken here near to what? This was near to n. Now, I will take, now if near to m, what to do? See, if it was near to n, we find 1 by n dou m by dou y minus 2n by dou x. Now, near to m means we find 1 divided by m, getting it, into the difference, that is dou m by dou y minus dou n by dou x, and that is taken as g of y. Here f of x, this is taken as g of y. Therefore, here the integrating factor will be nothing but e raised to integration of minus g of y dy. That is it. Very, very important. See, here in this case the integrating factor is, if it is near to n f of x, the integrating factor is e raised to integration f of x dx. But here if near to n, the integrating factor is e raised to minus g of y dy. Here it is e raised to f of x dx, and here it is e raised to minus g of y dy. That is it. So, what I told again, the integrating factor is something which when multiplied by the quotient makes it exact. Now, once it is exact, we know what the solution is. See, if it is exact, then the solution will be here, as you know. We have done it in the last video. Solution will be integration of m dx plus integration of n, only the y terms dy is equal to c. Solve as usual. That is it. Okay. So, this is the concept of reducible to exact form. So, once again let us summarize. Now, question will be given. So, m dx plus n dy is equal to 0. First check dou m by dou y is equal to dou n by dou x. If you equal exact, then the solution is integration m dx plus integration of n of y, only y term dy is equal to c. Done, as the previous video. But if it is not equal, then not exact, then step first, find the difference dou m by dou y minus dou n by dou x. See the difference is near to this m value or the n value. It should be little not identical, not same, it should be identical, the values. Okay. Now, if it is near to n, then we find 1 by n dou m by dou y minus dou n by dou x is equal to f of x. Near to n means f of x. So, the integrating factor becomes e raised to integration of f of x dx. Find it. But if it is near to n, near to what? n, then we find 1 by m dou m by dou y minus dou n by dou x is equal to g of y. Here the integrating factor will be e raised to minus g of y dy. Remember, minus g of y dy. Okay. So, once you get the IF, take the IF, multiply with the question, then put in the solution, you get it as the exact differential equation. That is it. So, one more thing to remember here, see, very important thing, e raised to integration f of dx, f of x dx, e raised to integration minus g of y dy. Sometime you remember this formula, e raised to log of something is equal to something, means to say e raised to log of x is equal to x only, e raised to log of x square is equal to x square only, say e raised to log of x raised to minus 1 is equal to x raised to minus 1 only. So, e raised to log means e and log vanishes, what remains is this terms. Which term? This terms remains x square x minus 1, that is it. So, it is very easy for you when you use this formula, whatever value you get, multiply with the question to make it exact and get a solution. That is it. So, we will understand in a very easy way once we solve some very important exam based problems. Okay. So, let us start solving the problems on ordinary differential equations of the first order reducible to exact form. Okay. So, now see, the problems which I will be solving here are very important. They have been asked many times in the VTU examinations for 6 to 7 marks. So, as you all do, you are the habit of doing it, simply watching the video, scrolling it will not help. So, please take a pen and paper or book or notebook whatsoever and practice along with me, so that these things get retained here and you put down in the on the examination paper and get good marks. Okay. And one more thing, if you are new to this channel, then please do not forget to subscribe, and also please share these videos with your groups, your study groups, your friends, your classmates as much as possible, so that each and every student gets benefited from this resource. Now, moving on to the problems. The first problem is solve 4xy plus 3y square minus x into dx plus x into x plus 2y dy is equal to 0. It looks like exact m dx plus n dy is equal to 0, but I need to check. So, as in the previous video, what is the condition to check for exactness? Dou m by dou y is equal to dou n by dou x. So, let us check it here. So, first I write here. So, from here we have m is equal to 4xy plus 3y square minus x, and n is equal to, let us make it more convenient by opening the bracket, x square plus 2xy. Fine. Now, dou m by dou y will be equal to, see here we are partially differentiating only with respect to y. I will keep on repeating this so that it gets fitted here in your brain and you understand the things correctly. Okay. Again listen, partial differentiation, I am partially differentiating only with respect to y. So, it is multiplied 4x as it is, do not touch it. Partial differentiation y with respect to y square plus, again here tell me what, y square 3 as it is, differentiation of y square with respect to y is 2y. So, it is 3 to the 6, 6y, and x there is no y term 0, that is it. The next is dou n by dou x. Here we are partially differentiating only with respect to x. So, x square means it is differential to x plus 2y as it is, differentiation of x is again 1. Fine. Now, you see here very fine, dou m by dou y, dou n by dou x, they both are not same. So, you write dou m by dou y is not equal to dou n by dou x. So, definitely it is not exact. So, what? It is not exact, since it is not equal to. Fine. So, not exact means what to do? Since for the VTU, as I already discussed this with you, we have only one type. Okay. So, we will follow the same type here. So, since it is not exact, we find a difference, find dou m by dou y minus dou n by dou x, and that will be equal to now what? 4x plus 6y minus 2x, be careful, minus you are applying. So, minus plus minus, again minus plus minus, minus 2y, and that is coming as 2x plus 4y. Again this will be 2 is common here, x plus 2y. So, when we do the difference, when we find the difference dou m by dou y minus dou n by dou x, we check if it is close to m or n. Based upon that our type works. Okay. So, now if you see this clearly, x plus 2y, see we have m n, let us see the question here only. See, this is m, this is n, see this is what? It is close to n. What it is? It is close to n. This is my n. What is what? Okay. X, it should be close to means little what? Identical. Are you getting it? Little what? Identical. So, I am getting 2 into x plus 2x, this term x plus 2y. So, it is close to or identical to n. So, once it is close to n, what we do? We find 1 by n dou m by dou y minus dou n by dou x. That will be now What is n here? We take as it is 1 by x into x plus 2y. What is the difference I am getting? 2 into x plus 2y, and here this cancels, x plus 2y cancels, and what do I get? I get this as 2 by x. So, this is taken as what? F of x. See the theory again, roll back to the starting of the video, see the theory. When it is close to n, we find a difference 1 by n, 1 by n, dou n by dou y minus dou n by dou x, and that whatever value you get is taken as what? F of x. Agreed? Fine. So, you got f of x here. So, from this you can easily find the if. What is if? Integrating factor. So, I will do here. So, my integrating factor is equal to integrating factor if will be equal to now, what is the formula? E raised to close to n means e raised to integration of f of x dx. Okay, that is again equal to e raised to integration of what is f of x? 2 by x dx. Fine, integration. Now that would be e raised to 2 integration of 1 by x dx. So for this all mathematics we are using simple integration stuff here, just a basic formulas required. So differentiation of log x is 1 by x. So integration of 1 by x is what? Log x. What is integration of 1 by x? Log x. Remember it, integration of 1 by x is log x. So we have this as nothing but e raised to 2 log x. Fine. Now integrating factor is a value, okay, e raised to 2 log x, because as we discussed e raised to log of something is e raised to log of something, e raised to log of x is x only, e raised to log of x square is x square, log of s, e raised to log of x cube is x cube, e and log cancels. But here I cannot make that form, 2 log x is there. So what I will do, I will use the property of logarithm. So you know the property of logarithm. What is property of logarithm? K log a is equal to log of a raised to t. I hope you remember this. Okay, k log a is equal to log of a raised to t. So using that, I can write here. I write here if is equal to, that implies if is equal to a raised to log of x square. Now this makes sense. Why? K log a log a raised to k, 2 log x log x raised to 2. Getting it? Simple basics. Therefore, now what happens here? According to the relation e raised to log of that something is something, e and log cancels. E raised to log of x is x, e raised to log of x square is x square. So beautiful, I get integrating factor as what? X square. So my integrating factor is what? X square. So as I discussed, the integrating factor is a function or a value which when multiplied by the quotient makes it exact. When I multiply the quotient, automatically dou n by dou y is equal to dou n by dou x is exact, and you can get a solution. That's it. Okay. So now let's multiply it here. So I'll multiply by the same thing. So we get implies, I'll do it here only, it's convenient. So 4 multiplied by x square x cube y plus 3 x square y square minus x into x square is x cube into dx plus x square into x square is x to 4 plus 2x cube y, correct, x into x square x cube y dy equals 0. Definitely this is exact. There is no need to verify dou n by dou y minus dou n by dou x, because the question will be asked around 6 to 7 marks. So it is understood. Okay. So by multiplying by the if, the question becomes exact. Now when it is exact, the solution as you know is m dx plus n only y dy is equal to 0, only y terms. So write a solution here, therefore implies the solution is integration of 4 x cube y plus 3 x square y square minus x cube dx integration of m all terms dx plus n only the n term only independent which has independent y are constant, no x is allowed, n only y terms, x raised to 4 not allowed 0, x to y no, we need plain y terms are constant, no x allowed. So, there are no plain y terms or constant here. So, simply 0 dy is equal to what? C, that is it. Therefore, let us integrate this, implies 4 as it is, integration x cube is what? X is to 4 by 4. See, this is a very simple integration, as you know, integration of x is to n is x is to n plus 1 by n plus 1, that is it. X is x square by 2, x square is x cube by 3, so on. So, x cube is x is to 4 by 4, 3 plus 1 by 3 plus 1, that is it, okay, into y plus 3, integration of x square is x 2 plus 1 by 2 plus 1. So, x cube by 3 into y square minus x cube is x is to 4 by 4, and obviously 0 dy is 0 is equal to c. So, here 4 cancels, 3 cancels, so that implies the solution is x raised to 4y plus x cube y square, am I right? 3 cancels, minus x raised to 4 by 4 is equal to c. Beautiful solution. So, this is how we solve a reducible to exact form. Let us move on to the next problem here. It says solve x square plus y square plus x into dx plus xy dy is equal to 0. So, let us solve this in a very easy way. So, first we check if it is exact or not. Now, we have here m as x square plus y square plus x, and we have n as xy. Okay. So, the condition for exacts we check here now. So, we have dou m by dou y is equal to, again partially differentiate only with respect to y, x square 0, y square is 2y and 0. Similarly, dou n by dou x only the x term, so y as it is, partial differentiation of x with respect to x is nothing but 1, that is simple as that. Now, both are not same, dou n by dou y is not equal to dou n by dou x. So, we have dou m by dou y is not equal to dou n by dou x, that means it is not exact. So, when not exact, what to do? The type which we followed in the previous question, the same type, we find a difference. So, find dou m by dou y minus dou n by dou x, and that will be equal to 2y minus y, that is equal to what? Y. Okay. Now, we check this, the difference near to what? See, we have this m term and this n term, okay, and here now this y is near to n again. See, xy should approximately match, n is xy, this is y, near to what? N again. Getting it? It is near to n. Fine. So, the difference dou m by y minus dou n by x is near to n. That means we find, therefore, that implies 1 by near to n means what? 1 by n dou m by dou y minus dou n by dou x is equal to, what is n? 1 by xy into y, and here the y and y term cancels. So, we have this as what? 1 by x, and when it is close to n, the factor 1 by n dou m by dou y minus dou n by dou x is taken as f of x, that is it. So, we have the f of x here, which is 1 by x, right. So, after finding f of x, we find a very important term to continue this question called as integrating factor. So, we have implies the integrating factor if equals e raised to integration of f of x dx. Fine. So, that is e raised to integration of 1 by x dx, very simple integration, that is e raised to log x. And what is e raised to log x? We already know e raised to log of something is the same thing. E raised to log of x is e and log cancel, what remains x. So, e raised to log of x is x. Okay. So, we have x as what? The integrating factor. Now, as you know, integrating factor is a value or a function which when multiplied by the question makes it exact. So, we will exact means what? Dou m by dou y is equal to dou n by dou s. There is no need to check it. Okay, it is understood. So, what we will do is simply multiply the if, that is x, by the question here. So, it implies we write here as, see, if is what? X. So, multiply by m and n here. So, if you multiply by x, we get x cube plus xy square plus x into x is x square and dx plus x into x is x square y dy is equal to 0. Now, as you know the solution, this is already exact. When we multiply by the integrating factor, it becomes exact. So, the solution is what? M dx plus n only y dy is equal to c. So, you do the solution here, that implies solution is m with respect to all the terms. So, x cube plus xy square plus x square dx plus n only containing the y terms, independent y terms or constants. There is no plain y terms or independent y terms or constants here. So, we will take 0 dy is equal to c. Now, let us integrate this. So, integration of very simple integration, x cube is x is to n is x is to n plus 1 by n plus 1, fine. X cube is x is to 4 by 4 plus x y square as it is, integration of, since we are integrating with dx, x integration is x square by 2 plus integration x square is x cube by 3 plus 0 is equal to c. Therefore, the solution for this question is x is to 4 by 4 plus x square y square by 2 plus x cube by 3 is equal to c. That is all. So, this is the solution by reducing it to exact form for the given question. That is it. The next problem is solve y into 2xy plus 1 dx minus x dy is equal to 0. It looks simple. Now, let us check what is the solution for this. So, first we will write m and n and verify it is exact or not. If it is exact, okay, otherwise we have to reduce it. Okay. Now, we have here, let us open the bracket, it will be convenient, m is equal to 2x y into y is y square plus y, and we have n is equal to minus x. Okay. Am I right? 2x, okay, fine. Now, dou m by dou y will be equal to, we need to partially differentiate with respect to y here. So, x is as it is, 2 as it is, differentiation of y square is what? 2y. So, 2y into 2 is 4xy plus y is 1. I hope you got it clear. Okay. 2x as it is, only differentiation of y, partial differentiation y square, sorry, is 2y. 2y into 2x is 4xy and partial differentiation y is 1. Similarly, here dou n by dou x, very simple one. So, minus 1. Okay. And you can see here that dou m by dou y is not equal to dou n by dou x. So, definitely not exact. If it is not exact, the type which are following, what we do? We find a difference, dou m by dou y minus dou n by dou x will be equal to, what is dou m by dou y? 4xy plus 1 minus 4xy plus 1 minus dou n by dou x. So, minus of minus become plus 2, right. So, this will be 4xy plus minus 1 plus 1, right. 4xy plus 1 minus 1 is plus 1, okay. So, 4xy plus 2, I can take here 2 common. So, this will be 2xy plus 1, fine. Now, seeing the question, you can easily check it is closer to m or n. So, tell me what now? See 2xy plus 1 here, here also we have 2xy plus 1. So, this is m and this is n. So, definitely it matches to, okay, it matches to what? N. So, we can write close to what? M. See here, this is what? Close to m here, closer to m. Fine. So, previous problems they were closer to n. Now, this one is closer to m, 2xy plus 1, 2xy plus 1. Fine. Close to m we find again 1 by m. Close to n means 1 by n dou m by dou y minus dou n by dou x. Close to m means 1 by m dou m by dou y minus dou n by dou x, correct. So, this will be now what is m here? M is, I take this as it is, it will be easy for me. Okay, I will not open it, I take it as in the question y into, because things will cancel here, 2xy plus 1. And what is my difference? It is 2 into 2xy plus 1. So, here now this and this cancels. So, we have this difference as how much? 2 by y, and that is taken as, if it is close to n, f of x. Remember, I repeat, close to n means f of x, close to m means what? G of y, what? G of y. Now, with this you will find the IF, integrating factor. So, you can write the integrating factor as IF equals e raised to integration of minus g of y dy. Okay. So, if the value is close to n, we take it as f of x, then integrating factor is e raised to integration f of x dx. But when it is close to m, we take the difference as g of y, that is the 1 by m dou m by dou y minus dou n by dou x as g of y, and the integrating factor is e raised to, be careful here, minus g of y dy. So, that will be e raised to minus or g of y 2 by y dy, that will be again e raised to minus 2 into integration of 1 by y is log y, since we are doing this to dy, integration of 1 by x is log x, integration of 1 by y dy is log y. Again the problem, this minus 2 here. So, what do we need to do here now? Tell me. So, minus 2 log y, again the logarithmic property, log a raised to k is k log a, or k log a is what? Log a raised to k. So, we will rewrite this again as e raised to log y raised to minus 2. So, what does the property say? E raised to log of something, e and log cancels, getting it? Okay. So, we have IF as equal to e and log cancels, y raised to minus 2. What is y raised to minus 2? 1 by y square. So, this is my integrating factor, that is it. Okay. Now, what is the integrating factor means? It is a value or a function which when multiplied by the question makes it exact and you can get a solution for it. Okay. So, let us multiply it here, I will do directly here. So, 1 by y square, see here carefully, m is 2xy square by y square cancel, what I get? 2x, fine, plus y by y square, we are multiplying 1 by y square by this question, okay, 2x y square by y square 2x, y by y square, y cancels, plus 1 by y, done, into dx, plus again, sorry, this is minus here, this is what? Minus, okay, x by y square, x upon, we are multiplying by 1 by y square. So, this will be what? X by y square, as it is, yeah, that is it, x by y square dy is equal to 0. Now, we have reduced this question to exact form by multiplying by the integrating factor. Now, let us find a solution which is very easy. The solution is integration of 2x plus 1 by y dx, only the m dx plus integration of only independent y terms are constants. So, x plus y square, there is no plane independent y terms or constants. So, this will be simply 0 dy is equal to c. So, the solution is 2 into integration x is x square by 2 plus 1 by y as it is. We are integrating with respect to x. Remember, integration of 1 exists because integration of 1 dx is x. 1 by y, do not take it 0 and all. People do this mistake in examination. Okay. We are integrating with respect to x. So, 1 by y is constant as it is. So, integration of 1 dx is x. So, into x is equal to c. So, the solution here is beautiful solution, 2 cancels, x square plus x by y is equal to c. This is the solution of the given question reduced to the exact form, as easy as that. That is it. So, my dear friends, that is all in today's video. I hope you clearly understood the concept of reducing the differential equation to its exact form and finding the solution. If you have any comments below, please drop in the comment box. I will be glad to answer them. So, see you in the next video on linear differential equations. Until then, keep practicing regularly, stay confident, and remember that every problem you solve brings you one step closer to success. Wish you all the best. See you in the next one. Bye.